So I want to start talking more about Actionscript programming again, and I want to start by talking about one of the basic building blocks of Actionscript programming, which is something called variables. You may have come across variables in mathematics. These are numbers which are represented by letters and can take any value. In computer programming, it's quite similar. Variables are data represented by a specific variable name that you give it. The one difference between computer programming and mathematics is that variables can only store specific types of data. So you set a type of data, and a variable can only store the type that you set it to store. As I mentioned, variables are identified by a name, and that is a case-sensitive name. So if you give it a name, you cannot change the case of the name that you've given it. And as I mentioned, the name and the type of the variable are set by the programmer. So let's look at an example. This is the int variable, which can store whole numbers. So 0, 1, 2, 3 and so on. Also negative numbers, these can be stored inside an int. And the way to declare an int variable in a program is as follows. You use the var keyword, var, all lowercase, then you give it a name, in this case myInt. By convention, I've used a lowercase for the first word and an uppercase for the second word. I would also use uppercase to start the words if I used any more words inside this name that I've given it. But I've used just one, so I've just made that I capitalized. Then I've put a colon in, and then I've put the type of variable, which in this case is an int. And this syntax is very, very specific. You'll see it all the time. It's always the same. So you've got var, the variable name, the colon, and the type. After that, it's completely flexible. So you'll see all kinds of different things used afterwards, which is the instantiation of the variable. So that's the declaration of the variable. You give it a name and a type, and you're saying it's going to be used in the program as a variable using the var keyword. Then there's the instantiation, which is storing something, or perhaps not storing something, inside the variable, and that can be very flexible, very different for different types of variables and different types of circumstances in computer programming. So that's one way of setting up myInt. Another common way of doing it is to just declare it without storing anything inside it, and then instantiating it, storing something inside it separately on another line somewhere else in the computer program. So let's have a look at actually declaring an int variable in a real program. So this is a Flash program I've set up with a text box here. I've called that output text, the instance name, so I can refer to that in Actionscript. Inside the timeline, I've set up an actions layer, wrongly in fact. Let's put actions, and let's put layer 1 there. That's fine now. So I've got my actions in that top layer. I'm going to put window actions to see that. And you can see how here I've got my var keyword, my variable name, my colon, my variable type. I've instantiated it in the same line as I've declared it. And then in the output text, we're going to see the output of that variable. And I'll say what I'm doing with this string later on. For the moment, don't worry about that. Another way of more commonly doing exactly the same thing is to use the trace function, which we've used on many occasions, and that just prints out what's inside the variable to the output window. In this case, I'm putting the variable outputs to a text box. So let's test that. So it's just reading 0, which is what I've stored inside the variable. And if I changed it to a 1, the output text will change to a 1 as well. If I declare it and instantiate it on a separate line, that should work. There should be no problem there. Yep. What happens if I just instantiate it? Sorry, if I just declare it and don't instantiate it? So I've not actually stored anything inside this int. I've just declared it, which is bad programming practice if you're then going to use it. But let's see what happens. And I've used it, an uninstantiated variable, and it said it's 0. So by default, something has been stored inside my variable, even though I haven't specified what it is. This is generally bad programming practice if you're going to use it. So just something to be aware of. It will automatically instantiate to be 0 in the case of an int. I think I've said enough on ints for the moment. Booleans, I'm going to talk about that in another lesson. We've already come across it, in fact. It's a variable that can only take true or false. I'll just mention that Booleans are objects, unlike ints, and I'll talk a bit more about that in a minute. And the reason I'm going to leave it is because in another lesson on if statements, I'm going to be talking about comparison and logical operators. We'll be using Booleans all the time. So I'm going to skip Booleans. Numbers I will talk about though. Numbers, unlike ints, contain numbers, but numbers contain numbers with decimal point. Ints only contain whole numbers. And I just mentioned Booleans are objects. Numbers are also objects. Most variables you'll come across, most variable types you'll come across in Actionscript are objects. Like I mentioned, they have a capital first letter, unlike an int, which has a small first letter, although in this case, because it's at the start of the sentence, it has a capital, but usually you'll see it just with a small I. Ints are known as primitive variables. Primitive variables are variables that are more closely associated with computer hardware, how data is actually stored in the computer. Objects are kind of designed to have functions and properties associated with them, so they're more contrived variables. They're designed for specific functions, in this case to store a decimal point after the number, and they can have properties and functions associated with them, unlike primitive variables, which are purely data. I'll talk about the isNaN function in a second as well. So let's try making a number. I can make it like this, instantiate it by telling it what it is there. I can instantiate it in another way. This is specific to objects. You'll have to use this on many occasions with most objects. You use the new keyword and then say the type again, and then in brackets you could either leave that out and not instantiate it, or instantiate it with a specific data, in this case 1.5. So let's just see it working, just so we can convince ourselves that it does. What happens if I don't instantiate it, if I just declare it? As I mentioned, this is bad practice because I'm using an uninstantiated variable. In this case it's saying NaN, not a number. And if you're doing some data validation or something along those lines, you might come across this function isNaN, which can test to see if a number is a number or an NaN. If it's an NaN, it returns true. So I could, if I cut that and paste it in here, so now in output text we'll see the output from isNaN. Let's test and see. And because it is NaN, it's saying it's true. So that's a Boolean output. And I think I'll leave number there and talk finally about strings. So strings are variables that can store sequences of characters. You can instantiate them using double quotes, and most variables can be converted to strings using a technique called casting. So let's have a look at this casting thing. So I'm going to create a string. I could use the new keyword because string is an object, or I could just simply put 1.5 in quotes if I wanted to without the new keyword. So I put 1.5 as a string inside my variable. The reason I want to do this is because I want to demonstrate casting, which is what we've been doing actually the whole lesson. We've been putting a variable type in front of parentheses, and then putting the variable inside the parentheses to change it into that type of variable, the string, so it can be displayed inside output text. I'm going to make a new variable called myNumber. So I'm going to make another number variable, and I'm going to instantiate it straight away as a cast of the string. So the cast here with the string like that. I'm going to put it in my output after I've added 1 to it. So I'm going to perform a mathematical operation on it just to prove that the cast is working. So it started out as a string, and we're converting it into a number, adding 1 to it, and putting it back into a string again using casting. So I'm going to go control test, and you can see because it's added 1 successfully, our casting has worked. So casting is changing one variable to another, and this is also a very good demonstration of the flexibility of instantiating a variable. I've instantiated it as the output of a cast, but I've declared it in the usual way: var variable name : variable type. So that's really all I want to talk about in terms of variables. So let's summarize what I've said. There are many different types of variables to store data in Flash programs, including int, boolean, number and string, and there's many more that you'll come across as well. Data is assigned to variables using the equal sign. This is also called instantiation, whereas declaration is where you are first showing that a variable is going to be used in a program, and it's used in a very specific syntax involving the var keyword. So you'd say var, then the variable name you will use, then colon, then the variable type. The instantiation is incredibly flexible. This is simply giving a value to the variable, and there's many different ways you can do it, and it will also depend on whether the variable is of an object type or a primitive type, and the vast majority of variables in Actionscript are of the object type, so you will normally see the new keyword being used. And we will be looking at variables and using variables in all subsequent lessons involving Actionscript. So in the last lesson I talked about variables in Actionscript, and I said they were ways of storing data in computer programs. In Actionscript there's a very specific syntax to set them up. There's a var keyword, the variable name, a colon, the variable type, and then the rest of it is flexible. In this case it equals 0, In the next example, which is a Boolean, it uses new Boolean. And the new keyword, as you recall, is always associated with an object type of variable. An int is an example of a primitive variable, and that's similar to how computer hardware stores data, whereas an object is associated with or can contain functions and properties. Properties in themselves are variables, so they're a more complex type of data storage. And the objects that you've come across so far, Boolean, number and string, these are all unusual in Flash because you can set them up. In fact, without using the new keyword, I could have just put, in place of new Boolean, in parentheses false, I could have just put false. And you can see here with the number, there's no new keyword used. With the string, again, there's no new keyword used. These are like irregular verbs in a language. They have a specific ways that you can, if you wish, to set them up. And they're also some of the most common objects that you'll come across in Flash, but the vast majority of objects will require you to use this new keyword when you instantiate them. So in this lesson I want to talk about using something called Adobe LiveDocs. And Adobe LiveDocs allows you to find out how to use the functions and properties of any object. And it has a URL, it's a website, and I've given it here. And I want to use it in this lesson to investigate string functions and properties. So let's have a look. The URL is quite complex, so it's easy to go to a search engine and then just type in Adobe LiveDocs. You can see it's come out at the top there. So that's the link I've given you. I've already got it up on my screen, in fact. So I said I was going to search for a string, and there's a search box up here, which I can type in string, and then go search. So I found the string. It's the top entry, so I just click on that. You can see it's a string AS3. If you're not on the Actionscript 3 version of LiveDocs, then you'll need to change your URL. I can scroll down a bit. It says there's public properties. Don't worry about what public means for the moment. And also public methods, which is another way of saying functions. And you can see there's actually nothing listed underneath here. The reason for that is that I haven't set a runtime, and you may remember from several lessons ago that you can use Actionscript to target various different operating systems. If I wanted to use Air, I will be targeting perhaps desktop or mobile applications. If I wanted to use Flash Player, I will be targeting the internet. And so I'm going to target Flash Player in this case. So I'm just going to click on that. You can see that some properties and methods have appeared. The reason that they won't appear unless one of these is selected is because objects can have different properties and methods depending on the type of software you are creating and what you are targeting. Are you targeting a desktop or are you targeting the internet? Because you can have different functions potentially available to you if you are targeting different software platforms. So let's have a look at the first and only property of a string, and that is something called length. And the length of a string tells you how many characters are in that string. And as I said, a property is a type of variable associated with an object. And as this is a variable, it has a type associated with it as well. In this case it's an int. And the reason they've chosen to use an int to define the length variable is because you can only have a whole number of characters, and ints will only store whole numbers. So it makes sense for the length property to be an int. Let's have a look at using the int property. I showed you this software in this application in the last lesson. It just outputs the property to output text. So let's have a look at the length property. I've made a string here, var my variable :string equals, and then I've put a string. And I've said that this string has 29 characters. And we can find out if that statement is correct using my variable .length. To use functions and properties, you need to use the dot syntax. So this is finding the length of this particular string. So I'll go control test, and it is indeed 29 characters. So let's have a look now. If I wanted to find out more information about the length, I could either click on this URL, or I could scroll down to where it says length, and then it will give me some more information. The same is true for all these functions. Let's have a look at the first function to see what that is. You can see it's got the same name as the object itself. It's a string, and that's called the constructor. And the constructor is a way of telling you, in this case, how to instantiate the object. So you can imagine that there should be a new keyword here. So you put var my variable :string equals new string, and then parentheses, and then it says you can put inside the parentheses a string. And you'll find a constructor associated with all objects. It tells you what you can put inside the parentheses, or in many cases what you have to put inside the parentheses in order to set one of these up. So in the case of a string you don't actually have to, because as I said, it's one of these kind of irregular verbs. You can set it up with double quotes instead. But the formal way of setting up, instantiating an object, is to use the new keyword and then putting a string inside those parentheses. And it will give exactly the same result if I compile that. 29 characters in that string. So that's all that is meant by the first function there. The rest are in alphabetical order. The first one is just different. It's a constructor. So let's have a look at the car@, which is a proper function of this string object. So instead of saying length, I'm going to say car@, and let's find out what car@ does. Returns the character in the position specified by the index. The index is in the parentheses. So it's saying that if I put a 0 inside car@, it will come out with the first character of that string. If I put in a 1, it will come out with the second character of the string. So let's test that. I'm going to put a 0 in. I'm expecting it to be a capital T. Control test, and it is. If I put a 1 in, I'm expecting it to be an H, and it is. And this convention of starting at 0 is used quite frequently in Flash, so it's worth getting used to the fact that the 0 is the first thing, the 1 is the second thing, the 2 is the third thing, because that is very often the case in Actionscript. Let's have a look at concat. Concat combines strings together to make a larger string. So I just need an extra string here, as I can concatenate var my new string equals plus a bit. So I'm going to concat my new string onto my variable. So I should have a larger string of those two joined together, and that's what has happened. There are other ways. There's another more commonly used way of concatenating. That is to use a plus. So I control test that, it's done the same thing. Another way of doing it would be to put in the double quotes directly and removing that string object altogether. That would come out with the same result. And I think we've seen enough of those for the moment. You can have a look at more of those yourself if you wish. But I'm going to leave you with a challenge just to make sure you understand how to use Adobe Live Docs. So create a number variable and store 1.234567889 inside it. Then use Live Docs to find out how to set the value to 2 decimal places. So it'll look like this, 1.23. Then cast the output to a string. You'll remember in the last lesson I told you how to cast one variable type into another variable type, and then concatenate the casted output with a currency sign. It can be a pound sign or it can be another currency sign, and in order to give something that looks like a currency amount, so £1.23 in this case. And I'll go through how to do this in the next lesson. So in the last lesson I challenged you to create a number variable and store this number inside it, and then use Adobe Live Docs to find out how to truncate it to 2 decimal places. Then cast it to a string and then concatenate it with a currency sign to give this result. So let's see how you would go about doing that. So I've set up the same application that I've used in the last couple of lessons. Window Actions to see the Actionscript. You can see I've set up the variable here, var my variable :number equals the number, and I'm using the number casted to a string to set the text property of the output text field on the stage. So if I control test that, you can see it's being displayed. But I only want part of it to be displayed, so I'm going to look at Adobe Live Docs, which I have here. You would have to first search for number inside the search box up there. I already have number showing. It's AS3 which I want, Actionscript 3. I have the runtime selected, Flash Player. So I'm just going to scroll down a bit because the function I want is this toFixed function. I could click on it to see more details, but basically it's just going to set it to a certain number of decimal places. So if I go back to Flash and then I put toFixed 2, then I could control test that. You notice that I've got it cast to a string here. In fact, it turns out when I look at the function and the output of the function is not a number this time, it's a string already. So I'm using a function with a string output, which means I don't need to cast it to a string. So I'm just going to take that out I'm going to control test again, and you can see there it is now working. And I'm going to put my currency sign in, concatenate it with a plus. I could use a concat function, but that basically completes the challenge. So let's go back to the slides, because in this lesson I want to talk about functions, and I'll be coming back to the toFixed function in a minute. But first I'd just like to talk about the basic syntax of a function. The function keyword, then you would give the function a name. By convention it starts with a lowercase letter, and any other words start with a uppercase letter. Parentheses are then used, open and closing, then a colon, and then an output type. In this case, void means that there's no output. Then there are an opening and closing curly bracket, and then there's some code within those brackets. And to execute that code, you have to write elsewhere in the program outside the brackets. Normally anyway, you would then write the function name, my function, use the parentheses and the semicolon. So, why use functions? Well, you would use functions when you want to use code more than once in the program. And the reason you would do that is it saves time writing code. You can just call the same function again and again. You are less likely to make errors if you just use functions rather than rewriting your code. Your code also becomes easier to read, especially if your function names correspond to what your functions do. You also have to use functions in certain circumstances. For example, we've come across this before when using event listeners. We used functions to listen to those events. And I'm now going to talk about functions with inputs and outputs. So I've shown you the basic structure of a function. This is a function with inputs and an output. You can actually only have one output with a function. But the inputs go inside the parentheses. You can tell the function what you want to call your inputs. They can be any name you give them. They're separated by a comma. You also, like for a variable, you have to use a colon and then give it a variable type. The same with the output. You use a colon, you give the output a variable type. This particular function adds the two inputs together and stores that inside a newly declared variable, and then it returns that variable. The return statement is required when there is an output type, so when it's not a void, and inside the return statement you have to have something with the same type, in this case an int, as you specify in this statement here, with the output type being an int. And the way to execute this code, to add those two inputs together and return the output, the sum of those two, you have to use the function name, but you also have to include in the parentheses the inputs, and they have to be integers. So I've used an example of 1 and 2 separated by a comma, and I've made that function equal to a newly declared variable, which I've made as an int, and that is going to store the output of this function into that variable. I'm just going to go back to the toFixed function, because if you look as part of the information, you can see the same kind of syntax being used here. So function toFixed, then there's parentheses. Inside the parentheses there is a type of integer, and that's where I put the number of decimal places that I wanted to set a number to. and the output to this function of a number is a string, and that's why I didn't have to cast the output to a string because it was already a string. So you can use this information here to find out what type of input you have to put inside the parentheses of a function and what type of output you will get when you use it. So let's have a look at an example in Flash. It's the same type of application as usual, and I've set up the addition function here, function add numbers, open parentheses, close parentheses. Inside there's two inputs, both of type integer. The output of the function is an integer. The function declares a variable, adds the two inputs together and stores the result inside the newly declared variable, and returns the variable as the output, the output being an int as specified. So when I call this function, which I do at the top here, in the slide I did it underneath, it doesn't matter whether it's above or below the function when I call it. I'm calling it here and I'm having as the inputs 1 and 2 as I showed on the slides. The output to this function is being stored in a newly declared variable here called myCalculation, and I'm using that variable inside a second function that I've created called printOutput. That's the function down here. That has one input, so this myCalculation becomes this to print. So this can be confusing at first. When you call a function, you put in a variable name. That variable is copied into whatever you call the input in the function parentheses. So this to print becomes the same as the contents of myCalculation. So when I call this, I'm sending the value, well, it's 1 plus 2, I'm sending 3 into the printOutput function, and 3 is then being used in this statement. So the number 3 is being cast to a string, and then the 3 in a string format is being used to set the text property of the output text field. So when I control test, the output is 3. One other thing you need to be aware of when using functions is something called variable scope. And all that variable scope means is that if you declare a variable outside functions, they are accessible both outside and inside functions. However, if you declare a variable inside a function, that variable is only accessible between the two curly brackets. And in fact, variable scope just doesn't just refer to functions, but in any case where these curly brackets are used, the scope of a variable is limited by these curly brackets. So if I removed that comment sign and used this variable here and removed the same variable from there, I wouldn't be able to refer to this variable elsewhere in the program outside this function, because the scope is from that position to this point, and then it's inaccessible beyond that closing curly bracket. So in summary, I've shown you functions of objects using the dot syntax, which you can refer to in LiveDocs, for example, the toFixed function. But I've also shown you how to write your own functions, including functions with both inputs and an output. And if you use an output, you must use the return statement. And as I mentioned, one of the key advantages of using functions is to avoid the unnecessary repetition of code. And we'll be using functions throughout our coding in Actionscript over the next few lessons. But in the next lesson, I want to talk about something else. I want to talk about something called an if statement. So in the last lesson I talked about functions, and there will be an opportunity to remind you about how those work in this lesson. Although first of all I would like to talk a bit about if statements. And we have come across if statements before in previous lessons. If statements basically test for a condition, and if the condition is met, the code inside their code block is executed. And if statements can also be paired with something else called an else statement, which is optional. And if the condition is in the if statement is not met, then the code in the else statement would be executed instead. So it makes sense in terms of the English language. If a condition is met, execute this code, else execute this other code. And I will show you the syntax on how to create an if statement in a minute, but first of all I would like to talk about comparison operators. Together with logical operators, these are how you create the statements that you are able to test using an if statement. So it's important to understand how these work. And these comparison operators are used mainly with numerical values, but also sometimes with other types of variables, such as a string can be used with this double equals. Double equals means is it exactly identical to, and there's another one here, is greater than, is something greater than something else, is less than, is greater than or equals to, is less than or equal to, and is not equal to. All of these will yield a Boolean output. So let's have a look at some examples. 5 double equals 5. Is 5 exactly equal to 5? Yes, it is. So it gives true. Is 5 exactly equal to 4? No, it's not. So it gives false. Is 5 greater than 4? Yes. Is 5 less than 4? No. Is 5 greater than or equal to 5? Well, yes, it is equal to 5. Is 5 not equal to 4? Well, yes, it is not equal to 4. It's different from 4. So you can use the outputs of those comparison operators. They yield Boolean outputs, and they can be used with these logical operators, because these logical operators, instead of comparing numerical values, they compare Boolean values. And they compare them in a very specific way. So this AND statement, the double ampersand sign, will compare two Boolean values, and it will yield a Boolean itself. All of these yield Boolean outputs. So if you have an AND and you have two true statements, the AND will yield true. If either of the two statements, or if both of the two statements, yield false, the double AND will also yield false. So both of them have to be true. So true and true gives true. For the OR, it's slightly different. True or true gives true. True or false also gives true. False or false gives false. The not only operates with one Boolean value, so not false is true, and not true is false. So let's have a look at some examples. I gave this one already. True and true gives true. True and false gives false. Here are some comparison operators which yield Booleans. 5 is exactly equal to 5, which is true. 5 greater than 4 is also true. True and true yields true. True or true, as I've just said, yields true. True or false also yields true. Not true is false. So here is the if statement syntax. The if statement makes use of, it can make use of logical operators and comparison operators, and it will test to see if the whole statement is true, and if it is, this code will be executed. If it's not, this code will be executed. So if variable 1 is greater than or equals to 10, if that statement is true, or if this statement if variable 2 is exactly the same as variable 3, if that is true, then this code will be executed. If both of these statements are false, then the other code in the else statement will be executed because it's an or statement. Remember that the else is an optional extra and the if can stand alone without the else. Let's have a look at some examples. I've got my usual type of application and I've built in some functions. I haven't executed any of these functions yet, so if I go control test, none of the code will be executed. If you remember, in order to execute the code inside a function, you have to write the function name outside that function first. So if I compare this and add a number in there, the reason I'm adding a number in there is because I've set up this function with a number input, an integer input. So this is saying I need to put a number inside those parentheses. The output of the function is void, there is no output, so I'm not worrying about the output, there's no return statement. But this 9 goes into this variable to compare, which can be used then inside the function, and I'm using it with an if statement. So if to compare is greater than or equals to 10, another function is going to be executed, and this function accepts a string input. Print output is actually down here, so this function print output will accept a string input, has no output, it has void there, and then this string is used to set the text property of the output text field, which is on the stage. So whenever you see this print output, that's just saying send this text to the stage. And because I'm putting in 9 into this function, it's going to be compared in the if statement. If 9 is greater than or equal to 10, execute this code. 9 is not greater than or equal to 10, 9 is less than 10, so this is going to be a false statement, which means that this code isn't going to be executed. This code will be executed instead. So I'm expecting it to say less than 10. And that's what it's doing. If I put in 11 in here, 11 will go into this value in the function. It can be used here. 11 greater than or equals to 10 gives true, which will run this code in the if statement. So it's going to say greater than or equal to 10 when I test it. If I just delete that so that function doesn't run anymore. The next function down is logical and. This function I've set up to have an int variable input and a Boolean input. And as you can see, those can be both used inside this if statement. So if I just write some code to run that function, I just have to use the name of the function. So I put logical and 5 true. The reason I have to do that is because the first one has to be an int, so I've just decided to put 5. The second one has to be a Boolean, so I've decided to put true. So this if statement now is going to use those two values to make a statement, and it's going to test that statement to see if it's true or false. So is 5, this to compare, greater than or equal to 10? No, it's not, it's false. And is this enable comparison, which is true? Is true exactly the same as this double equals? Is true double equal true? Well, yes, true is exactly the same as true. So this is going to resolve as true. So I've got a false and a true. And if you remember, I said that and will only yield to true if both of the things it's looking at are true. Otherwise, it will yield a false. So this if statement is going to resolve this statement, and it's going to say it's false. So it's going to ignore this bit of code and run instead this bit of code with the else statement logical AND returned false. If I make the number greater than 10, so now both of these will be true, the AND will return true. And so the first bit of code is executed. And I can do something very similar with the next function, which is exactly the same, except that an OR is being used instead of an AND. So we have 5 or true. 5, remember, gives false. In this statement, is 5 greater than or equal to 10. That's false. True, exactly the same as last time. Is it identical to true? Yes, it is. So we've got a false or true. And if you remember, the OR, if it sees either of these as being true or both of them, it will yield a true. So this if statement is going to be true if I write these two values as 5 and true. So it's returned true. If I make both of them false, it will return false. So I hope you're getting the hang of this if statement and function business. If I now just do the last one, logical not, if I put a true in it, you might expect it's going to say false, because as I said before, it's going to give the opposite, and that is how I've set up this function. So it's taking a Boolean input and then saying, is this input, the reverse of it, is that equals to true? And I've put in a true, so is the reverse of true, is false, exactly the same as true? And no, it's not. It's going to return this second statement instead when I put in a true. And the opposite will happen if I put in a false. But I think we've seen enough of the code for the moment. You can look at it later on your own and test things out. But in summary, if statements execute code if the statement they test resolves to true, and we create a statement using a combination of comparison operators, such as the double equals, the greater than, the less than. And we can also use those with logical operators, the AND, the OR, and the NOT. And in the next lesson we'll be using functions and if statements, and in fact everything we've learned so far, to create an actual application. So in the last few lessons I've been showing you how to use functions, variables, and if statements. And I want to pull together all those different concepts into an application, which I'll show you how to create. It will take more than one lesson to show you this, so I'll be showing you in this lesson and the next lesson how to put this particular application together. And what it does is it selects itself a number between 1 and 100, and then you try to guess what that number is. So I've typed in 15, that's too low. I've typed in 90, that's still too low. 99 happens to be correct. So I'll also be giving you a project to do. It's going to be a timer, but I'll give you that in the next lesson, and then in the lesson after we'll be looking at how to incorporate the timer into this game. So I've set up an Actionscript file, and I've created a background, and I've put on it some rectangles with different colours, and I've locked that layer, and then I've created a new layer, and I put text on that layer. You can see all the different things that are on that layer. I've embedded the text to make sure it's viewable on every computer. This first text box I want to be accessible in Actionscript so that I can look at the guess number. So I've given that an instance name, and I've also given it a type of input text. That means I can edit the text when I have the application compiled. I have another text box here. I've called it info text. That's dynamic text. It can be edited by Actionscript. I've also created two buttons and given those instance names: submit button and reset button. So I've got all this set up, but I haven't got any Actionscript yet. So I'm going to go Window, Actions, and the first thing I want to do is to set up mouse event listeners for the two buttons, because that's an obvious thing that needs to be done with this software. So it's a good place to start. So submit button, add event listener. Mouse event, make it a click mouse event. Well, I've chosen to call the function on submit. Now writing the function, you'll see that it has the same structure as a usual function. So it has an input, which in this case is a mouse event type of variable. I could call this something else if I wanted to, and I can refer to that within the function. It doesn't have an output, so it doesn't have a return statement. And I can test to see if it works using an using a trace function. Sorry, if I go control test and I test it, you can see it's working there. And I need to do exactly the same for the reset button. So I'm just copying and pasting to avoid introducing any errors that I might introduce by retyping everything. I can test this one works as well. For some reason that isn't doing. Okay, that's because I haven't changed that. Always a good idea to test it to make sure everything's working. Now I can see it is. So the next thing I want this software to do is to select a number, because what I want the software to do is when I guess a number, it has to have something to guess, to test the guess against. It has to know a number in its own software. It has to have a variable somewhere that contains a number that I'm trying to guess. So I'm going to call it number to guess. I'm going to make it an int type of variable because it's a whole number that I'm trying to guess. I could, if I wanted to, make it a fixed number, but that would be a boring game because every time you played it, it would be the same number. So instead of doing that, I'm going to show you a new function of the math object. You can look at it in LiveDocs if you want information about it. It's called mathRandom, and I'm going to use the trace function. I'm going to cut and paste that into the onSubmit just to show you how it works. So when I press onSubmit, it's going to trace the output of the random function. So you can see those are some random numbers it's creating there. They're all between 0 and up to 1, but not including 1. And they're all numbers with a large number of numbers after the decimal point. So there's going to have to be some changes before I can make it a number between 1 and 100, the whole number. First thing I'm going to do is to multiply it by 100. Now you can see, because I've done that, each of these random numbers is being multiplied by 100, so it's looking like it's in the right kind of range. Although because the random number I'm multiplying goes from 0 up to 1 but not including 1, that means when I multiply it by 100, the numbers that result are going to be from 0 up to but not including 100. Whereas I want it to go from 1 and include 100. There's a number of ways I could deal with this. I'm simply going to add 1 to it. The output's going to look very similar. If I click enough, you might see 100, but I'm not going to spend all day doing that. And the final thing I want to do is to change it into an int. I could cast it into an int. So you can see there I've got the right kind of numbers being created randomly. I could also use a function called mathFloor if I wanted to, instead of casting it to an int. That does exactly the same thing. So I'm going to use that particular function instead of 37 to store the result of this mathRandom. I'll change that back to an int again. It stores the result of this mathRandom multiplied by 100, has 1 added to it, it's casted to an int, it's being stored in this variable. I just cut and paste that trace. You'll be able to see when I test the program, a random number has been selected at the start. So now I have a number to guess in my program. So what do I want the program to do with this number to guess? So when I guess my own numbers, I want it to compare the number I guess with the number that it has selected the number to guess. So I wanted to compare this value with this value, and then I want it to say something in this box. Either it's too high or too low. So let's create a new variable that's going to hold the contents of this box. I'm going to make it a number rather than an int this time. Var my guess number. I'm just going to declare it, I'm not going to do anything else with it. Why am I choosing to use a number rather than an int? Well, because I could put in a number with a decimal point. Could put in a number like that. Could even put in some text. So what I need to do with this number is to test that it is in fact a number that I'm dealing with before I do anything else with it, because I can't compare some text. I can't compare some text with this integer. It has to be a number, and before I can make this test. So there's a function I can use to test that out. It's called isNaN. But before I use that, I want to store the contents of the guess box here, which I've called guessText, inside this variable. So my guess equals, I'm going to cast it to a number, guessText.text. The text property gives the string inside the text field. It's casted to a number and stored in this number. You recall that variable scope means that if I declare it outside, it's available from the point I declare it, so it's not available above that point. It's available from the point I declare it all the way downwards through the program. If I had declared it inside this onSubmit function, I would have access to it from the point I declare it until the function closes, but then I wouldn't be able to refer to it outside. So I've chosen in this case to give it a scope that includes outside the onSubmit function. And I'm going to use an if statement to find out if that number is a number or if it's not a number. Is NaN my guess equals false. So if it is a number, is NaN is going to be false, because this tests to see if it is NaN, which means not a number. If it's NaN, it says it's true. If it's actually a number, it comes out with false. So if NaN, my guess, is false, the if statement will resolve this whole statement, and it will say is false exactly the same as false, and it will say yes, that statement is true. So it's going to say in my trace function is a number, because I just want to test it out. I'm going to put an else in, which is going to run in the event that this is not a number. It's not a number. So if I control test that now, and I put in here a number, and I submit that, it says it is a number. If I put in a capital G, it says it's not a number. So I'm going to leave the lesson there. I will just summarise what I've done so far. I've set up event listeners for the two buttons. So the submit and the reset button have event listeners added to them. The functions here correspond to the functions here. So when they're clicked, the function is run. The software has set up a random number and it's stored it in this this variable here, number to guess. I had to use math_random to create the random number, and I had to multiply that by 100 and add 1 to it and cast it to an int in order to get the right range of numbers, and also to make sure they're whole numbers. Then I'm taking my guess from the input, the guess input, guess text field. I'm casting that string into a number, storing it in this variable I've declared, and then I'm testing it in an if statement to make sure it is a number. And then in the next lesson I will be processing that number to check to see how it compares with number to guess. So I'm just carrying on straight from the last lesson. I've added some comments to the code. So event listeners, some variables declared here. This function onSubmit, which is called whenever a user clicks the submit button. And currently what it is doing is validating the contents of the guess text field, which is on the stage. You can put in a guess there, and when you click on submit at the moment, it's being validated to make sure it's a number. So let's continue, because when we've validated this, we want to compare it to the number that's been generated by the software, which we did on this line, using math_random, multiplying it by 100, adding 1 to it. So the way we're going to do that is to use an if statement. But before I do that, I just want to check, as well as it being a number, I want to check that the input is a whole number that the user has put in. So I'm going to use an AND operator for this. I'm going to cast the number to an int and check to see if the int version is exactly the same as the number itself, because if that is the case, then the number itself must have been an int in the first place. And so this AND operator makes sure that this code is only executed when both of these statements are true. So if my guess is an int, and if my guess is a number, this code will be executed, and if not, this code will be executed. So let's test that out. If I put in something that's not a number, saying it's not a number. If I put in a number but not an integer, still saying it's not a number. If I put in an integer, saying it is a number. That's because I haven't changed the trace, but it should say it is an integer now, but never mind. We can see the basic principle, it's working. So let's remove those trace statements, and instead of having a trace statement in this else part of the code, I want to set this text box to warn people to put in an integer. I've called this info text, so I'm just going to copy that and put that into the else code block there. The text property allows me to change the text inside it. Please enter a whole number. If I test that, control test. If I don't put in a whole number, it will say please put in a whole number. So I've got the data validation all set up there. So now I want to compare the number to the randomly generated number, which I'm going to do with an if statement. If my guess is greater than the number to guess, I'm still going to use this info text, but this time I'm going to say too high, because my guess will be higher than the generated number, so the guess will be too high. If I use less than, it's going to be too low. If I test to see if it's exactly the same as the generated number, in that event it will be correct. So I've got there all my comparisons. Actually, before I test that out, I'm just going to trace that to see what I'm aiming for. So I'm aiming for 67. I put in 66, too low. 68, too high. 67, it's correct. But I can still continue to check different numbers, and ideally after I've found the number I'm looking for, I really want it to stop allowing me to check different numbers until I press reset. The way I'm going to do that is to add in another variable. I'm going to call it playing game. At the start you can play the game. I'm going to say, well, you can't play the game when you've guessed it to be correct, but when you press the reset button you can play the game again. But in order to make sure that this is enforced, I'm going to have to test to see if playing game is true or false before I execute all this code. And so I'm going to have to put in an if statement. If playing game equals true, and these curly brackets have always got to correspond to each other. An opening one has got to correspond to a closing one. I'm selecting all this and pressing tab to make it easier to see where my curly brackets open and close. So if this playing game is true, this code can be used. Otherwise, if playing game is false, and that will happen when I've clicked the correct answer, so when I've guessed the correct answer, this code will no longer be able to be executed until I press reset. Let's see the effect of that. I'm looking for 32. If I test 31, it's saying too low. If I test 32, it's saying correct. test 31 again. Now it's not saying too low. But if I click on reset, and I now try 31, it will say too low, until I try 32 again. But what I really want to happen when I press the reset button is for the number to guess to change. Remember that the number to guess is set with this line. So let's copy that line over. And let's paste it in this place here, the onReset, which is the function that is called when the reset button is pressed. Because I've already declared the variable, I'm not going to use the var keyword or the type again, but I'm going to leave it like that because that will generate a new random number. I'm going to use the trace function to find out what that new random number is. And then I'm going to control test. So I'm at the moment looking for 47. Try 45, it will say too low. I try 47, saying correct. And now I can't do anything else until I press reset. And now I'm looking for 74. So when I try a number, I can do it again. It's now responding to my guesses until I guess correctly again, at which point it will stop responding to my guesses until I press reset, and then it selects a new number to guess. So that's the software now completed, except for the timer, which I'll talk about in a second. But before I do that, let's just go through how this works again. So we've got on our stage 4 things that can interact with Actionscript: the guess text, input text, the info text, which is dynamic text, can be altered by Actionscript, 2 buttons, the submit button and the reset button. And we've got event listeners, listening for mouse clicks on those 2 buttons. They've been written at the top. There's the onSubmit function, which is run when the submit button is pressed. There's the onReset function down here, which is run when the reset button is pressed. And I also declared some variables here, one of which creates a new random number at the start of the program. And what that allows me to do is when I click on the onSubmit button, it allows me to compare what I've entered in this box here with the randomly generated number. I'm doing that in the if statements here. If my guess is greater than the number to guess, the way I got my guess out of the text box was with this line, so I've cast it to a number. I'm also checking to make sure it is a number and an int. If it's not, then the info text says please enter a whole number, and that's just been set up as an if and an else. It's running the else if the if doesn't resolve to true. When I correctly guess the number, when my guess is exactly the same as number to guess, it says correct. And then this playing game latch is used to make sure I can't continue making guesses. So this is set to false, so this if statement will no longer allow this code to be run when I click the submit button until the reset button is pressed, which calls this function onReset, and that sets playing game to true again so I can make guesses, and it also generates a new random number. So that's how that software works. But I also want to add a timer to the software. A timer in this top corner. When you make your guess and submit, the timer starts. When you've guessed correctly, the timer stops. Then you reset and you make a new guess, the timer starts again. So I'm going to give you a project, which is to make a timer on its own. So there's the timer text. If you press start, these are seconds, these are minutes. Press stop, the timer stops. Press start again, the timer continues. Press stop again, the timer stops. Press reset, the timer goes back to 0. So that's the project that I'd like you to do yourself. If you're feeling very adventurous, you can try incorporating it into this Actionscript file as well. But first of all, I will just go through the basics of how to create a timer. What you need to look at in LiveDocs is timer. Make sure you've got a runtime selected. LiveDocs will tell you how to set up a timer. It will also tell you the functions that you can use with it. Let's go back to Flash, and let's set up a brief timer here. So var timer equals new timer. The delay is in milliseconds, so 1000 is a second. 0 means the timer will continue until it's stopped. I'm adding an event listener. That's going to listen for timer events. So I've got to add in the function as well. Let's put in a trace to see it working. Actually won't work at the moment. I'll show you why. Nothing's happening. Nothing's in the output. The trace isn't showing anything. The reason for that is I haven't started the timer. And to know how to use the start, the stop, the reset functions, you just need to look at LiveDocs. But I've just started it there. And every second now that function will be called by the timer. And it's using that trace function every second, which shows it works. So that's the code I'm going to give you. I'm going to point you to the LiveDocs for more information on the timer, if you wish to look at it. And I'll show you it again, what I want you to do. I will go through it in the next lesson. Seconds, minutes, when you click on the start, it starts. Stop, it stops. Start, it starts again. Reset, we'll set it back to 0. So in the next lesson I'll show you how to do that, and also how to include it in the Guess the Number application. So in the last lesson I gave you a project which was to create a timer with a start, stop and reset function. And I'll show you how to do that in this lesson. So I've put some text on the stage and I've given it an instance name, timer text. I've also created some buttons which I've also given instance names. And in the Actionscript window actions, I've copied over the Actionscript from the last lesson that I gave you to show a demo. Before I go through that, I'll just quickly mention that these import statements that appear automatically are simply to allow me to use the objects that I've referred to later in the code. So this line here is setting up the timer. You will remember from the lesson on variables that the vast majority of variable objects in Flash require this new syntax, new timer in this case, and in parentheses I've put in a timer delay, in this case 1000 milliseconds, which is 1 second. The 0 means that the timer should continue in perpetuity. If I had put another number in there, say for example a 5, it would continue for 5 cycles before stopping. And I got that information out of the LiveDocs. I've got timer up here. I scrolled down to find the constructor which has the same name as the object I'm using. It tells me how to create the object. I clicked on it and I read this information and I found out that the delay refers to milliseconds and the repeat count refers to how many times the timer cycles. I can also use LiveDocs to look at the functions, one of which is the start function, which starts the timer. I've also added an event listener. Events are also referred to in LiveDocs. In this case it's a timer event, and when I've started the timer, this function will be executed every 1 second in this case, because that's the delay that I've set. So every second this code will tell the trace function to write it works. Let's control test to make sure it does. So every second that's being written onto the screen. When I was creating the guess the number application, the first thing I did was to add event listeners to the buttons. I'm going to do the same thing here. In fact, I already have done. To save myself writing it out, I've just created mouse event listeners and linked them to those 3 buttons, the start, stop and reset buttons. I've also created functions, so when each of these is clicked on, the corresponding functions will be executed. So I want the timer to start when I hit the start button. So at the moment the timer.start is in the wrong place, so I'm going to cut that out and I'm going to put it in the start function. I'm also going to add a stop and a reset. So now when I control test, I shouldn't see it tracing it works until I click the start button, and then it should say it works every second until I click on stop. And the reason for that is because the buttons are now controlling when the timer starts, stops and resets. And that controls when the timer events can be created every second, and that means that this function will be running when the timer is started. But of course I don't want it to say it works every second. I want it to increment a number in this text box. Although before I increment a number in a text box, because a text box contains a string, I really need to be working with an integer. So I'm going to create an integer. In fact, I'm going to create 2 integers because there are 2 numbers in this text field. There's a seconds and there's minutes, and I'm going to treat those separately. So I'm going to create separate integer variables. Let's call them minutes and seconds. And when the onTimer function is called, I'm going to increment seconds first of all. I'll just show you that happening with the trace. So I'm incrementing seconds. So when I hit the start button, seconds is incrementing by 1. And by the way, ++ means to increment by 1 each time. It's exactly the same as writing +=1, which is also the same as writing seconds equals seconds plus 1. But for short, I'm going to write ++. You could also write -- if you wanted to subtract 1 every time. Of course, I don't want seconds to be counted all the way up to 60 and more. Every time it gets to 60, I want it to reset back to 0, and also increment the minutes by 1. I'm going to use an if statement to write that in computer code. If it's greater than or equal to 60, I want it to be set to 0, and I want the minutes to increment by 1. So again, we can trace seconds. I'm just creating a concatenated string here in the trace function, which will show both of them. And I'm going to start my seconds at 55 rather than 0, so that it's clearer that the minutes increment. So I'm going to go control test. I'm going to click start. Seconds going 56. And you can see the seconds went to 0 after 59, and the minutes have increased to 1, which is what I want it to do. So let's set that back to 0 again. Of course, I don't just want it to be in the trace, I want it to be here. I want the seconds and the minutes to be registered in this timer text. So let's set that up. Timer text.text to refer to the text property equals, and I'm going to put minutes first. Then I'm going to concatenate the colon, and then I'm going to put seconds in. Let's see what happens when I do that. I press start. Now you can see it's not looking quite right there. There's no leading 0 when the number is below 10. So to fix that, I'm going to have to put in another if statement. So if seconds is less than 10, or if seconds is more than 10, I want something different to happen. So if seconds is less than 10, I want a leading 0. If it's more than 10, I don't. So let's see that happening. Let's set my seconds a bit higher, so it's clear that it works. When I click start, starting on the 6 there, you can see the leading 0 is working. Let's put that back to 0 again. I also don't want to do the same with minutes, but it's quite difficult to do them both at the same time, unless you're going to add in nested if statements. So that's one way of doing it. I could put in another if statement, but I'm going to do it in a slightly different way. I'm going to create a timer string, and I'm going to gradually build up the string each time. So I'm going to add minutes to the timer string first, and then I'm going to add on seconds to the timer string afterwards. So let's put if minutes is less than 10, timer string is going to be 0 plus, let's cast it. I don't actually need to cast it in this case because the context, I've included a string there and added a string addition, a concatenation, so I could leave the casting out because there's a context. The context will cause automatic casting. But in this next one I'm going to have to use the cast. It would create an error otherwise. So if minutes are less than 10, I'm going to include a leading 0. Then for the seconds I'm going to then add to the timer string. So I'm going to say timer string equals timer string plus, so that's including what is already in the timer string. I could also use plus equals as a shorthand. I'm going to include that part of it, and I'm going to make the timer text on the stage equal to timer string. I'll do the same in the else, but without the leading 0 in the seconds. So if I now go control test, it should work, although we can't tell yet because we're at an unsuitable set of values. Let's go to a more suitable one. Let's start at 9:55. It's got 9:56, got the leading 0 there in the minutes, and you can see that's working properly, and this is also working properly. So the timer string gradually adding to it is working correctly. And if I test that again, I could also see it stopping because I'm controlling the start and stop from the functions linked to the mouse events. But if I click on reset, this isn't currently changing. So what I want to do in reset is to set the timer text back to its original value. But if I test that out, it's not going to work properly still. If I now go stop and reset, it's gone back to 0. But notice my seconds are still on 58, my minutes are still on 9. It's going to carry on from 9:58. So I have to put seconds back to 0, minutes back to 0. I'm going to set these ones to be 0 initially as well. And now when I use my reset, it should go back to the beginning, and it is doing. For completeness, let's see what happens if I click on start and reset without pressing stop, and it just stops. So that timer is working now. I'll just go over briefly how it works again. So I've set up on my stage some text which I've given an instance name, and 3 buttons which I've also given instance names. To the buttons I've added mouse event listeners, and those functions are controlling whether the timer is started, stopped or reset. The timer I've set up here, I've given it a delay of 1000 milliseconds, and it's going to cycle in perpetuity. So when I click on the start button, because I've added an event listener to listen for timer events on the timer that I've created, this timer function will start to be executed every second, and that increments this seconds value. I've declared the seconds and the minutes up there. If seconds reaches 60, seconds is reset, minutes is incremented. We've got a trace that shows that. And then I need to format the minutes and seconds in such a way that it can be displayed on the stage in the timer text. So I've used a timer string to gradually build up the formatting. I'm using is minutes less than 10 to find out if I need a leading 0 or not. And then for the seconds, I'm adding on the seconds part to the timer string to create the full timer string, including the minutes and the seconds. And then I'm using the timer string to set the text property of the timer text on the stage. So that's happening every second after I've clicked on start. If I click on stop, that stops happening. If I click on reset, the timer text on the stage is reset to 0, seconds and minutes are set to 0, and the timer is reset, ready to start again. So that's how you would set up a timer. I've added the same code to the guess the number. I'm not going to go through that in this lesson, but if you want to have a look at the code, there'll be some code that you can look at associated with this lesson. And we're going to be continuing with Actionscript over the next few lessons, learning more techniques and aspects of Actionscript, and then we'll be looking at another project which will tie together everything we've done so far. In this lesson I want to talk about something called arrays, and arrays are ways to store groups of object variables together in such a way that they can be referred to by an index number. And what I mean by that is that you can use a number associated with an array to refer to an object variable rather than using the variable name in the usual way. And this is very useful when you want to perform the same computational operations on many similar object variables. And I'll show you an example in this lesson. Here is an example of an array being created. It's a variable, so it uses the same syntax that we've come across before. The var keyword is used, and then I've given it a name. Then there's a colon, and then there's the variable type. Then I'm using the new keyword with the same variable type again to instantiate that object. And I mentioned that arrays store groups of objects, and you will sometimes see things appearing within these parentheses, separated by commas. That's a way of storing things in an array. Another way is to use the index notation. So the way you do that is to use the name of the array that you've given it, along with some square brackets, and then you can refer to individual elements of the array using a number inside that square bracket. So in this case, the number 0 means the first element of the array, and I'm making that equal to a new string. So I'm basically storing this new string inside the first element of the array. And I could then refer to the string that I've just stored by using this array index notation later in the program. So I could just refer to my array and then in brackets 0, and that will be referring to this array element. And as you can see, array indexes start from 0. And if you want to look at some functions of arrays, then they are in live docs. But I won't talk about those in this lesson. I will show you an example of setting up an array in Flash. So I've got a Flash file here. I've put some squares onto the stage, which I will refer to in a minute. But to start with, I just want to show you this array that I've set up. var myArray colon array equals new array. And I've stored 3 strings inside that array using the index notation. So I've got 1 being stored into the first element, 2 being stored into the second element, and 3 being stored into the third element. And I can now refer to those strings using the index notation with the array. And I'll show you an example. So the second element of the array is myArray 1, and that should show 2 because that's what I'm referring to here. So let's go control test to make sure that works, and you can see there it is indeed working. And I've put some things on the stage, and I've also commented some code out because I want to show you something. I'm just going to comment that code out now. I'm going to comment this code in. So I'm now storing square 1, square 2 and square 3 inside the array. So the reason I'm doing that is because I want to show you that you can store things on the stage inside arrays. And in fact we'll be looking at that in more detail when we come across application programming in this section. But I just want to show you the principle. So square 1, square 2 and square 3 are the instance names. I'm storing those inside my first 3 array elements. And now instead of referring to the properties using the instance names, I can refer to the properties of those squares using the array and the index notation. For example, I could set the x positions of these squares to be 0. I'll just do that now using the array and the array index. So I'm using the dot syntax actually on the array and the array index notation itself. So I'm putting the dot syntax in there, and then I'm referring to the x property. So I'm doing exactly the same as what I would be doing if I was doing this. So that's referring to the x property of square 1. But instead of using square 1, I'm just substituting this array index notation for the instance name. And let's have a look at the compiled result. You can see at the moment the x positions of these squares are all different. Now they're all 0, and that's been achieved using an array index notation along with the dot syntax to refer to the properties of the things that are stored inside these array elements. But of course this isn't an efficient way of referring to the properties of these array elements. The advantage of using arrays is so that you can perform these type of computational operations more efficiently and more simply than referring to 3 separate operations as I've done there. So we need to have a look at another piece of the puzzle, which is something called a for loop. And the for loop will allow me to look at each element of an array in sequence and perform computational operations on each element. And I will only have to write the operation I want to perform once, and the for loop will allow me to do the same thing to each element of the array. So let's look at how we would set this up. So I've created an integer variable here, and I've set that to 0. I've also created an array, var my array colon array equals new array, and in this case I'm storing 3 elements inside this array, 3 strings in this case, and I'm putting them inside the parentheses, and they will take positions 0, 1 and 2, the first, second and third elements of that array. And I'm going to now set up my for loop, which I've done here. So what a for loop allows me to do is to use an integer variable, and in each iteration of the loop the variable number will change. So you can see there's 3 separate sections to this for statement here. And they're separated by semicolons. There's I equals 0, I is less than myArray.length, and I++. The first bit allows you to set the start point for the integer. The second bit allows you to set the end point. And the third bit allows you to control the behaviour of I between loops. So in this case it's incrementing by 1. That's what I++ means. So I'm starting from 0. I want to go to the array.length. If you trace this myArray.length for this array, it would come out with 3. There's 3 elements in this array. But because of the array index notation starting at 0, 0, 1 and 2, I actually want my I to go up to 2 and not 3. So that's why I'm using less than myArray.length rather than less than or equals to. If I had put less than or equals to, I would go to 3. And then that would generate an error because there isn't anything stored in positions, the fourth position with index 3. So this is something to be careful of. You only want to refer to elements of an array that have something stored inside them. So that's why I'm using less than the length rather than less than or equals. So now that I've set this for loop up, I will increase by 1 each time, and it will allow me to refer to each element of the array. I substitute the array index numbers with the I because the I is going to change in each iteration from 0 to 2, and that will trace each element of that array to the screen. Let's have a look at some examples of for loops. I'll just delete that code. You can imagine that this is very efficient when you've got a very large number of elements in your array. So I'm going to show you an example first of a very large loop. It's going to go through 100 loops. Now I'll just trace the I itself, and you'll be able to see how that works. Control test. So you can see here that the output has gone from 0 all the way to 100, incrementing by 1 each time. You could change the start position. For example, it could be 10. You change the end position to make it less than or equals to. You could put I equals I plus 2 in there to increment them by 2 every time. So this is all very flexible. So you can see in this case it started at 10, incremented by 2, and it's gone all the way to 30. I'll just show you one more example. This time I'm going the opposite direction, greater than or equal to 0, and then I minus minus, which means decrease by 1 every time. So I'm starting at 30. I've changed my sign from less than to greater than or equals to. Then I'm using I minus minus. Let's just test that out. You can see it started at 30 and gone to 0. So you can see how those for loops are working. So let's now set one up to work with my array. From I is 0 to I is less than my array dot length I plus plus. And I'm going to set my x positions, so I'm using I in place of the index number there. I'll set the x positions of those squares to 0. So that's going to look at, in the first iteration, it's going to look at I equals 0, my array is 0, dot x equals 0. In the second iteration, I is going to go to 1, so my array 1 dot x equals 0. Then finally, it will go to I equals 2, because that's the end position I've set. I equals 2 would be my array 2 dot x equals 0, and then that will stop looping. So you can see that this loop is going to look at each of the elements of this array and set the x position of each of those squares on the stage to 0. So let's see that happening. So you can see that working there. So I'm going to leave for loops for the moment. And I want to talk about something called multidimensional arrays, because arrays can store objects inside themselves, and they can store arrays inside themselves because an array is a type of object. So in this case I'm storing in the first element of an array another array with 3 elements inside it. Now if I want to refer to a particular element, the second element for example, of an array within an array, then the way I would do that is to use two indexes. So you can see that here the first index is referring to the first element of the main array, and the second index is referring to the second element of the array stored inside that first element of the first array. And that trace function would trace out the contents of that particular element of that array, which is 2. So this can get quite confusing, but it's just worth mentioning that arrays can be multidimensional because it's useful for certain problems. So in summary, arrays store groups of objects, and as I've shown you, arrays are often used with for loops to loop through each of the array elements using the length property to define the number of loops that you're going to use. I've shown you arrays being used with stage elements as well as objects stored inside them directly, and I've also showed you an example of an array being stored inside an array to create a multi-dimensional array. In the next lesson I want to talk about another type of loop called a while loop. I talked about for loops and arrays in the last lesson. For loops allow you to process elements of arrays efficiently, and we'll be revising for loops in this lesson. But I really want to focus on something called while loops, which allow computational processes to be repeated until a condition is reached. So it's a slightly different type of loop. So let's see how they are structured. So this is how you would structure a while loop. While, and then you've got a condition in parentheses. That's a Boolean condition. So while the condition is true, the loop iterates. And the loop continues to iterate until the condition is not met. So it's very important to make sure that within the loop the condition becomes not met. Otherwise the loop will continue indefinitely, and that's called an infinite loop and can cause bugs in your program. A similar loop is the do while loop. So the way you set that up is to use the do keyword and have a code block, and then the while statement is at the bottom. And while this condition is met, this loop will continue to iterate until the condition is not met. So it's important again to make sure the code changes this condition so that it's not met anymore. And the difference between the do while loop and the while loop is that the do while loop is executed at least once, even if the condition is not met. So this code is always executed. Let's have a look at some examples of these loops. So I've set up a while loop up here, and I've also set up an integer variable, and the condition for this while loop is that I is less than 10. So while I is less than 10, this loop will iterate and the value of I is traced, and also I is incremented by 1, so that's changing this condition because it will eventually reach 10, and then the condition will not be met and the loop will stop. If I commented this out, that would then be an infinite loop because I would always be 0, and the loop would just continue to be executed indefinitely because it would never be 10 or greater. So let's put that back in, and then let's have a look at the output to that program. So at the top here, that's the output to the while loop. So it's I is being traced and it's starting at 0, and then when it reaches 9, it's incremented by 1, and then it will be 10, and so it doesn't continue when I is 10. so that's why it stops at 9. This trace of a blank line just leaves a blank line so that we can look at another loop here. So this is a for loop. We looked at these in the last lesson. I just want to put this in here to compare with the while loop. So I said in the last lesson that there are 3 sections to a for loop. The first section is where the integer starts from. The second section says where the integer will stop. And the third section says what happens to the integer in each iteration. So this for loop is starting at 0, ending at 10, and incrementing by 1 every iteration of the loop. So the output of that is here. It's starting at 0, going to 9 because I put it less than 10 rather than less than or equals 10. And I've set up a do while statement as well, a do while loop. So I've set I back at 0 again. This is tracing an output of I and incrementing I, much in the same way as the while loop did. The condition is also the same, while I is less than 10. So we have the output of the do while statement there, going from 0 to 9. And then finally at the bottom here, I just wanted to show you the difference between the do while and the while loops. So I set up a Boolean variable called latch, and I've set that to be false. The conditions of these 2 loops, I've set latch equals true there. So the condition is not met in both of these loops. But with the do while loop, the code is always executed. So this is traced. And let's see that. Do always execute at least once. And in the case of the while loop, this code is not executed because it checks at the start to see if the condition is met, and because it's not met, that code is not executed. So let's have a look at an example of using while loops. And the example I'd like to show you is how to shuffle 5 numbers randomly. So the way I'm going to do this is to use a for loop to go through each number one at a time, and then for each number I'm going to randomly generate a number between 1 and 5. So in the first instance here I must have generated 4 randomly. In the second instance I could have generated 4 first. So imagine I generated 4. I will have to check what I've previously generated to make sure that I don't repeat the numbers, because I want each number to appear once. So if I got a 4, then I'd have to generate the number again. So imagine I got a 4 the first time, and the second time I tried, I got a 5. So this is actually a loop that's required here to generate a number until a number appears that hasn't appeared before. And that type of loop is a while loop, because you're looking for something until a condition is met. So let's have a look at that code. I've set up a flash file here with 5 numbers. Each of these text fields has been given an instance name, digit 1, digit 2, digit 3, digit 4 and digit 5. And I've stored those inside an array which I've called digit array. So digit array is referring to the text fields on the stage. And then this first for loop here is looking at each of those numbers in turn, as I mentioned on the slide. I've got to look at the first one first, then the second one, then the third one, So that's what this first for loop is doing. It's going from 0 to the length of that digit array, which is 5, and incrementing by 1 every time. And then, as I mentioned, I need a while loop. I've actually set it up as a do while loop. And what this is doing is finding out, well, it's first of all generating a random number between 1 and 5. We've seen something like this before. Math random times 5, cast to an int, and then add 1 to it to get a number between 1 and 5. And then we need to find out if we've seen this number before, if we've already used it. And I'm using a second for loop here to find that out. So this for loop is going from 0 to the I position we're currently looking at. So for example, if we're looking at the digit 2 or digit 3, we would only go up to the previously used numbers with this for loop, because it's going up to I and incrementing by 1 every time. And this is the if statement that's testing to see if we've used the number that we've generated before. So is the number exactly the same as a text of the digit array j? J is the numbers of the digit array that we've looked at previously. And if we find that we have used it previously, this Boolean value is set to false. So it's set to true initially. If we find it, then it's set to false. But if it's not set to false, that means we can use the number that we've generated here. So if found equals true, then the text field that we're currently looking at can be set to be the random number. And this continues. If we did find a random number, then this found would be false. So we'd have to do this do while again and generate a new random number. And we continue to do this until we've got a unique number, and then we can fill in the text field. Then this condition is not met, and we can move on to the next number in the array. So that's how that works. So let's just see it working. Control test. So we've got a purple 3, yellow 2 and green 5 there. Let's test it again. We've got a purple 2, a yellow 5, a green 3. Test it again, it's changed again. So each time it's it's shuffling those numbers differently. So let's just briefly go through that again, because that's quite complicated. So I've set up an array, and I've stored the text fields inside the array on the stage. Then for every one of those text fields, I'm going through them one at a time. And inside a do while loop, I'm generating a random number between 1 and 5. Then I'm testing to see if I've used it before in previous text fields. And if I haven't, then I can use it in the current text field. But if I have, then I have to go back and do this while loop again, this do while loop again, and generate a new random number. And I continue until I find a unique random number between 1 and 5 that I can put in the text field that I'm currently looking at. And in fact, we'll be looking at a shuffling function in the application programming we're doing in this section as well. So this is a useful introduction to shuffling. So in summary, for loops are often used to loop through array elements, whereas while and do while loops iterate until a Boolean condition is not met, I suppose. So until the condition is met, but it's actually until that condition is false. And infinite loops are a common programming bug. And what you have to do is to make sure that inside your while and do while loops, the condition is changed, and that makes sure that that at some point the while and the do while loop stops iterating. And in the next lesson I will be talking about something called a switch statement, and then we'll be returning to this kind of shuffling and application programming in a following lesson. I just want to leave loops for the moment and come back to if statements. You'll recall that if statements execute code if a Boolean condition is met, and they can be paired with else statements that execute code if the condition is not met. And we've been using if statements for several lessons now, and you should be quite familiar with these. Something related to the if statement is the switch case statement, and it's similar to using an if statement with the double equals operator, which means if something is the same as something else. But unlike the if statement, it allows you to execute separate code depending on the contents of the variable that you are testing. And it also has the option of using something like an else and an if statement, where you don't find a condition you're looking for. You can execute code using the default keyword. So let's have a look at an example of a switch statement. So I'm wanting to test a particular variable I've set up here. It's a string variable, and I've stored Monday inside it. And I've called the variable weekday. So I'm using the switch statement with weekday to test for different conditions, different contents of this variable. So what is happening here with the syntax? Use the switch keyword, you have curly brackets there to enclose the switch statement, and then this keyword case is used with each of the different conditions that you're testing for. In this case I'm testing for days of the week, and then after the condition you're testing for, you put a colon, then you put the code that you want to execute, and then you put a break statement. And what the break statement does is it prevents any other code from being executed in that switch statement after you've executed the code that you want. So let's test this out. I'm looking for Monday, so I'm switching Monday, case is Monday. This particular statement should be read to the screen. Switch statement output first day of the week. Ignore the second output for the moment. Switch statement output is first day of the week. That's correct. If I put in Tuesday instead and test that, it's now saying it's the second day of the week. If I put in something that isn't a day of the week, such as January, what will happen is the code under the default statement will be run. The default is optional, much like the else statement. And what it will say is it's not a day of the week. So you can see that that's working. You can actually build something like this switch statement with ifs and elses. So I'm showing you how to do that down here. So I'm testing for Monday first, and if it is Monday, some code is executed. But if it's not, then move on to this next code block and test to see if it's Tuesday instead. And then some separate code is executed. I could continue nesting these if statements. I could put an if inside this other else statement to test for Wednesday. And I could test for Thursday in the next else statement, and so on. But you could see that code would look untidy, because it would be a very large number of ifs and elses all nested. So the switch case provides a a more easy to read version of the same thing. But I can show you that this nesting works. I put in Monday again. If statement output the day is Monday. So it's seen that weekday is equal to Monday. It's outputting that. Oops, I just wanted to show you Tuesday. If statement output is now saying it's Tuesday. The reason for that is because when it came across the condition for testing for Monday, it's saying, well, it's not, so I'm going to execute this else statement, and then it's testing to see if it's Tuesday, and it found that it is. So you can see how a nested if statements can be built to test for multiple conditions and execute different code in each case. But the usual way of dealing with this type of problem is to use the switch statement. So switch, and then in parentheses put your variable that you want to test, then use case, and then put the conditions you want to test for after each case, the code you want under it, and then a break statement. So in summary, switch case can be used in place of an if statement, where you would use the double equals operator, so we're testing for something being the same as something else. And if you want to test for more than one condition, and if you want to execute different code in each case. And as I've showed you, the default keyword acts much like an else statement. And in the next lesson we'll be moving on to some more application programming and pulling together all the concepts that we've looked at so far. So in this lesson I want to show you how to create a small application. It's a sliding game, so let's show you how it works. I've just shuffled those tiles, and I can now move the tiles around to try and create the original image. It will take more than one lesson to show you how to do this, so let's start on this. So I've created assets on the stage, so let's show you those. Created some layers up here. The bottom layer I've got some tiles in there, and each of these tiles, if I just double click on that, it's a movie clip with several frames in. I created it with insert new symbol and then put in these images that I've imported to the library. File import to library. I created these sections of images with Photoshop, and I've just put them inside the frames of this movie clip. Now the last one is a blank tile, and that's what allows me to have one blank tile to move around. So let's just come out of there. So all of these are the same movie clip with the same 9 tiles inside them, and that allows different tiles to occupy the same space. This one here is the last tile, and that only displays at the start of the game because it's replaced by the black tile for the purposes of the game itself. So that's just on its own. I've given it the name last tile. I've given the tiles themselves instance names as well, tile 1, tile 2, and so on. The grid here is just a graphical grid to make it look nice. Overlays, because I want to make these tiles respond to mouse clicks, and you may actually find problems if you apply mouse event listeners to movie clips with several frames in. So to avoid any potential problems, what I've done is to create overlays, which are movie clips with just a single frame inside, and these are just rectangles. They're rectangles with an alpha of 0. The alpha I've set here. I started off as a black square, and then I made it invisible by using alpha to 0. That will allow me to add a mouse event listener to each tile position. I've given them instance names so that I can do that. I've got buttons that I've created using in the usual way. Insert new symbol and then add slightly different images to the 3 separate frames, and then add a hit area as well. Temp is a temporary layer which is just showing the tile numbers. I'll just hide that for the moment. So I've shown you everything here. This is on the stage. So let's go into Actionscript with window actions, and let's start programming the application. And the first thing I want to do is to put the tiles and the overlays into arrays. So I've created a tile array. And into each element of the tile array I'm going to put one of those tiles. So I could go on and put all 8 in there, all 9, sorry. But I'm just going to copy over from one I made earlier. And I need to do the same with the overlays as well. And I'm also just going to copy that over. So there's the overlay array, which refers to overlays. I'm also going to add event listeners to the 2 buttons. Let's just check what instance name I've used for those. So there's new game and reset game. So let's add event listeners to those. So I've seen these before. I just need to add functions to those. And the same with the reset game. And I'm just going to add one thing to each of these functions, and that's to make the last tile disappear when I start the game. I've called it last tile. So last tile.visible equals false, and when I reset the game I want it to appear again. I will compile it, but first I just want to make sure that the tile arrays are not going through a large loop, because at the moment they will just loop through all the different tiles. So let's just make sure that doesn't happen. So I'm going from I equals 0 to I is less than 9, and incrementing I by 1 in each iteration of the loop. And I'm going to make each tile stop at position at frame i+1, and the reason for that, if I just show you the squares again, so there's tile 1, tile 2, I want tile 1 to be on frame 1, tile 2 to be on frame 2, tile 3 to be on frame 3, and so on. So that's why I've put tile array I should stop at frame i+1. Unfortunately, there's an error. So let's have a look at our error. It will tell you the line number to look at, and it will tell you what sort of error it is. So it's line 42, and the reason is because I've put reset game there instead of on reset. So let's just change that over, and let's try again. Okay, so now that appears to be working. And if I put new game, a blank tile, or rather the last tile disappears, and if I click on reset, the last tile appears again. So that's fine. Okay, so I also want to be able to click on the overlays and have those respond to mouse events. So let's do that in the same for loop, because it's looping through 9 things, which is how many elements there are in the overlay array. I'll call that tile click. And let's trace tile clicked. So when each of these tiles are being clicked, the same function. The reason it's not quite doing it properly is because I've got this temp layer showing. If I just move the temp layer down for the moment underneath the tiles, then it will work better. Now notice it's not a button. I've used a movie clip, but I can actually make the mouse cursor respond as if it's a button by setting something called button mode. So now when I put the mouse over it, it changes to the button cursor. At the moment I can't distinguish between which tiles I've clicked. In order to be able to do that, I need to use a property of movie clips, which is the fact that a movie clip is a form of dynamic class, and you can see which classes are dynamic classes in LiveDocs. It will say right at the top, public dynamic class movie clip. And what that allows me to do is to add dynamic variables. I could call them whatever I want. I just need to put the dot syntax. I call this identity if I wanted. And I couldn't because that's a keyword. You know, it's a blue keyword. It means it's a reserved flash word. So I could probably use ID capitalized. No, I can't. I'm just going to use ident, but you get the idea. I can set a variable dynamically on a movie clip just using the dot syntax. I'm going to make it equal to I, so each overlay will have a different identity, and I can detect it down here. And I'm going to use the ident property, but in order to relate to what I've clicked on, I need to use this E property, this E variable. E variable contains what I've clicked on. The way I access it is to use the property current target. So this current target contains the overlay that I've clicked on, and the overlay that I've clicked on contains an ident. So I can look at that property that I've created dynamically on that movie clip. So let's have a look at what happens now. Now I can actually see which tiles I'm clicking on, which will be useful in the program, because I want the program to respond differently depending on which tile I click on. So now that I've got all the mouse event listeners set up, I want to be able to shuffle the tiles when I click on New Game. So to do that, I'm going to create a new function, and I'm just referring to it in this start game. But before I can start shuffling the tiles, I need to know how I can move the tiles when I shuffle them. Because if I just place them randomly, it might be that the game is then unsolvable. So in order to make sure the game is solvable, I wanted to actually move the blank tile randomly, but in positions that it can go to. So the blank tile starts here at the moment, and I want to know which tiles it can move to. So I need to know the connectivity of each tile, where the blank tile can move to. And that's why I've created this temp layer that shows these numbers on. Because what I'm going to do is to create an array that stores arrays for each tile showing the connections. So I'll just show you what I mean. Our connection array. So that's the main array, and in the first element of that array I'm going to make a new array. So this is a multi-dimensional array. I mentioned this in the lesson on arrays. And so the 0 is going to refer to tile 0, and then what's inside of the new array is going to be what it can connect to. In this case it's going to be 1 and 3. So I'm going to just put 1 and 3 in there. I'll do the same for 2. Sorry, the same for the first tile, or rather the second tile, but with index 1. So tile 1 is connected to 0, 2 and 4. And I need to continue doing that until I've got all the tiles and all their connections. But I'll leave that to the next lesson, where I'll continue straight off, and you'll be able to see that I've added all those in. So let's continue on from where we were in the last lesson. We were looking at how to build this application, and I was showing you how to shuffle the tiles. So you can see that I've added in all the extra elements into the connection array. So for example, you can see that tile 2 is connected to tiles 1 and 5. You can also see that on the stage. Tile 2 is connected to tile 1 and 5. And the strategy I'm going to use to shuffle the tiles is to keep track at all times of the blank tile position. At the start of the game that will be position 8, and that will be connected to tiles 5 and 7. And I want to choose one of the tiles that it's connected to. For example, I could choose randomly tile 7, and then I want to swap the image in the tile I've chosen with the blank tile. So then the blank tile will be in this position in that case, and then I'll be looking at the positions connected to that for another round of shuffling. So that's how I'm going to shuffle the tiles. And as I said, I want to keep track of the blank tile position, so I'm just going to write a variable to store that, and at the start it'll be at position 8. So I'm going to use this blank tile as an index to the connection array, and that will allow me to see the connecting tiles. So in the case of 8, it'll be 5 and 7 as I showed you. I want to select one of these at random. The way I want to do that is to select one of the indexes at random, so either 0 or 1, which will refer to 5 or 7 in this case. And to make a number that is either 0 or 1, I'm going to have to use the length of this array, the number of tiles connected to the blank tile, and then use that to generate the random number. So let's do that now. Generating a random number, which I want to be an integer. I'm using the mathRandom function, and I'm multiplying it by the connection array, the blank tile element of it. I'm using its length property. In the case of blank tile being 8, the length is 2, so this function generates either 0 or 1. And we can see that using the trace function. So in this case it's chosen 0, in those cases it's chosen 1, so it's just entirely random what it's choosing. So let's get our target tile using that random number. I'm going to get the target tile from the connection array. In the case of blank tile being 8, it would be 5 or 7. But to get it out of the connection array, I'm just using the random number in the second index of the two-dimensional array. I also want to find the frame that the target tile is on. And the reason for that is because, as you recall, all these tiles are consisting of symbols in the library, movie clips with timelines, which I created with insert new symbol, and just added one of these images to each frame. So you can see it here, it's changing down there. Each frame corresponds to an image. The blank tile is in frame 9, and the frame numbers are at the top there. So I want to find out the frame because that corresponds to the image, and it's the image that I'm going to be swapping over. So I want to find the target tile frame, the frame of the target tile that I've chosen. I'm going to use tile array to find this. Tile array gives me direct access to the tile on the stage because that's what I've stored inside tile array. So it's actually giving me access to tile 9 on the stage in the case of where target tile is 8. Although it wouldn't be at the start, it would be 5 or 7. But to get the current frame, you use the current frame property. So that's the target tile frame. It'll be either 5 or 7 at the start of the game. Now I want to swap the frames over. I want to swap the target tiles frame with the blank tiles frame. So I'm again going to use tile array to access the tile directly on the stage. I'm going to use the go to and stop function, and I'm going to send the target tile's frame number to 9, which will be the blank tile. And I'm going to use the same syntax with the blank tile. This time I'm going to send the blank tile to what the target tile, to the frame that the target tile had. I'm also going to set the blank tile's position, update it so that I always know where the blank tile is. It's now moved to the target tile. So let's test that out. It should now swap the images over when I click on New Game and run the shuffle function. So it's just shuffled one tile there, it's chosen one of the tiles and swapped the frame numbers over. So that looks like it's working. And it would be nice if I could reset that so that it goes back to the original picture. So I would click on the reset button to do that, which will run this reset function. Now setting the picture up was something I did towards the start of building the application. I have the code here in fact. So I'm running through all of the tiles in the tile array and I'm setting the correct frames which sets the correct pictures. So let's just paste that in. I'm also going to put a new variable in here which has the variable scope limited to this function. You don't have to do this, but it's what I am doing in this case. It's just good practice. So tile array 0 will go to frame 1, tile array 1 will go to frame 2, and so on. So that will reset the picture. I also need to reset the position of the blank tile, which will go back to position 8. So I can now shuffle a tile and reset the tile, shuffle a tile and reset the tile. You can see it's choosing one at random. Of course I wanted to shuffle more than one tile, which is why I'm tracking the position of the blank tile. So I'm just going to put the shuffle tiles in a for loop. I'll just shuffle it 10 times to start off with. Let's test that out. So it's shuffled a few of the tiles there. So that seems to be working. Of course I need more tiles shuffling. I'm going to try 1,000. If you try too many then there'll be a noticeable delay when you click on New Game because it will have to process the information that you're telling the computer to process. But that looks fairly instantaneous and it seems to be shuffling the tiles quite well. The next thing I want to do is to be able to move a tile next to a blank tile. So if I click on tile 5, I want that to move into the blank tile position and I want the blank tile to move where tile 5 is. That's like in the game that is completed and working. So that's what I want to do now. And you can see when I click on these tiles, I can see which tile I've clicked on. That's because I added a dynamic variable to the overlay, and that's what I'm seeing here. That's why I made the overlay a movie clip rather than a button, because a movie clip is a dynamic class which I can add a dynamic variable to, which I've called ident, and that's what I'm seeing when I click on the overlays. This is being read out here, tile, and then tile number, clicked. So I'm going to use this to identify what I've clicked on. I'm just going to store it as a variable, tile clicked. Now I'll just copy that over. And I also want to know the frame because I want to be swapping this over if it's next to a blank tile. So it's just like the shuffle function. So I'm going to be using the tile array again to access the tile on the stage that I've clicked on, and the current frame property to find what frame it's on. And now I want to find out if this tile I've clicked on is connected to a blank tile, or connected to the blank tile. So I'm going to use the connection array to do this. For example, if I've clicked on tile 4, I want to check every tile it's connected to, 1, 3, 5 and 7, and see if any of those are the blank tile. And if they are, then I want to swap those two tiles. I could use the amount stored in the blank tile and compare it, or I could use the current frame property of each of these tiles and see if it's equal to 9, and that will tell me if it's the blank tile. And that's what I'll do here. So I'm going to use a for loop. I'm going to go up to connection array, looking at the connections of the tile I've clicked, and I want to loop through all of them. And I want to look at each tile that the tile clicked is connected to. So that's the test tile. So looping through all of them, storing each into test tile in each iteration of the loop. Then I want to find out if this test tile connected to the tile I clicked is in fact the blank tile. So I'm going to test to see if the current frame of the test tile is 9, and if it is, that must be the blank tile. And in that case I want to swap the two tiles over. So I want to make tile array test tile, go to and stop the tile clicked frame. So I'm changing that blank tile to the frame of the tile I clicked on, and conversely I want to make the tile I've clicked on become the blank tile. So let's test that out and see if it works. Actually, I'll just move these tile numbers down in case they interfere with my clicking, my testing. So if I click on these corner ones, nothing's happening, which is what I want to see. If I click on the ones next to the blank tile, then they are indeed swapping, and they seem to be swapping correctly. So that's working. However, there is another thing I need to do, and that is when I complete the picture successfully, I want the last tile to appear. I don't want a blank tile in this position. But I'm going to leave the test to see if I've completed the puzzle to the next lesson. Let's continue from where we were in the last lesson. So I've showed you how to shuffle the tiles, and now I want to show you how to test for when the puzzle is solved, and when it is, we want this blank tile to be obscured by the last tile. I've also just added in a line to keep track of the blank tile there. That's when we're swapping the tiles over. But I'm going to check to see if the game is won every time we click on a tile, because it is possible that we could win the game or solve the puzzle when we've clicked on a tile. So it'll be the last tile to click on, and then we've solved it. So I'm going to create a Boolean variable called game1. I'm going to make it true to start off with. Then I'm going to test each tile, and if any of the tiles are in the wrong position, I'm going to change game1 to false. And I'm going to use a for loop for this, using tileArray.length, but I could just have put 9 in there, because I know that tileArray.length is in fact 9, because there's 9 tiles. And I'm going to check each of those to see if the current frame is not correct. So if it's not equals to, I'm going to put this in parentheses, much like in mathematics you can put parts of statements into parentheses like that. That will test to see if any of the frames are in the wrong position. So if the frame for tile index 0 is not 1, the frame for tile index 1 is not 2, the tile for frame index 2 is not 3, and so on. Those are the correct positions for the frames, and if they're not correct, then game 1 is going to be changed to false. So any of the tiles not correct, game 1 will be false. But if game 1 is true, we want the last tile to become visible. And obscure the blank tile. And to test this out, I'm shuffling too much really at the moment. I just want a small amount of shuffling. Then I can solve the game easily in a test. So you can see there's an error there, and that's preventing this from working. Let's investigate this error. The term's undefined and has no properties. At tile click you may find this. What that means is that something I'm using inside tile click has a null value. In this case it's because I just haven't put that in. So I just missed out the j is less than tileArray.length. But if you come across that error, that's all it means. You're using something that hasn't been instantiated. So that seems to have worked. Let's try that again. That seems to have worked again. But at the moment, the game isn't preventing me from continuing to click. So the blank tile is hidden under this last tile. So I can still click on this tile and it will swap. And I don't want it to do that. And the last tile has remained visible. So that's another bug in the program. And we just have to fix that by including a latch of some kind. I'm going to call the latch canPlay. I haven't declared this variable yet, but I'll declare it later after I've put it where I want it to be. And I want the canPlay to be false when the game has been won. Let's just copy that over. The reset function does a similar thing to winning the game. It resets all the tiles back to the original position and makes the last tile visible. So I'm going to put canPlay equals false here too. And when I start the game I want it to be playable, so I'm going to put canPlay equals true under the start game. And finally I'm going to declare it. And at the beginning I want it to be false, because at the beginning I haven't clicked on new game, the last tile is visible, so it's much the same as when I've won the game or reset the game. So at the start it's going to be false. Now in order to prevent me from clicking on tiles, I'm going to have to add an if statement here, and only allow myself to, or allow the user to be able to use the tile click function if canPlay is true. So that should now prevent the problem that I've just shown you. So now when I click on these two positions, it's no longer allowing me to swap those. So I can only click to swap the blank tile when the game is currently being played and this last tile is not visible. So that is now a fully functional game. I just need to change the shuffling back to 1000 again, and then it will play properly. So I can shuffle, I can rearrange the tiles, I can win the game, and I can reset the game and have another new game. So that's working, but I will just go through it all again in brief because it's quite a complicated game. So to remind you from the beginning, I've set up here tiles, which I originally used insert symbol and added 100 by 100 pixel image segments, which I made in Photoshop. And if I show you them, I've just double clicked on it. This is the timeline for those tiles. I've given those tiles instance names, and I've put those in an array. I've done the same with overlays. Overlays, if you recall, is because I don't want to add my mouse event listeners directly to something that can change frames, because that could possibly cause problems. And my overlays I made with a transparent square, alpha equals 0. And I'm using a movie clip rather than a button, because a movie clip will allow me to use the dynamic variable that I need to use in order to be able to identify which overlay I've clicked on. The alternative would be to add an event listener for each overlay, which would be 9 separate functions. And for convenience, I've just put the overlays in an array, and then I've gone through the array and I've added the event listeners to each overlay using the array. I've also set those movie clips to a button mode, which will affect the cursor appearance. Then I've used the dynamic variable, so this is a variable, a property that I've created myself. This isn't a property associated with the movie clip, with the symbol that I've added to the stage. This is one that I've just invented myself and called it what I wanted, and I've made that equal to the eye position as it's going through, so that'll be 0 to 8, and that's what allows me to identify what I've clicked on when I click on it. I also added event listeners to the 2 buttons, the start button and the reset button, and then I decided that I needed to shuffle the tiles when I clicked on the start, so I created a shuffle tiles function. And then in order to be able to shuffle the tiles, I needed to look at where the blank tile was, which at the start of the game is in position 8, and I said that I wanted a function that would look to see what the connecting tiles were, 5 and 7 at the beginning of the game, and then choose one at random, for example 7, and swap them over. So swap the frame numbers, which is the same as swapping the images. So the way I've set this up is to use a connection array. This is a 2-dimensional array that says what each tile is connected to. So for example, tile 2 is connected to tiles 1 and 5. And you can see that on the stage, tile 2 is connected to tiles 1 and 5. And then I'm using that information in the shuffle tiles function, because I can then use the connection array with the blank tile to select one of the tiles that's connected to at random. And if you recall, I'm also tracking the position of the blank tile with this variable. So I'm looking for a random number, either 0 or 1 in the case of blank tile being 8, so that I can look at the index, the second index of the connection array. So that's why I've set up here a random number, which is either 0 or 1 when blank tile is 8. So that will find my target tile using the random number as the second index of that connection array. and then I wanted to find the frame number of the target tile, and I used the target tile as the index to the tile array, which is where I stored all the tiles originally. So this is the tile on the stage that I've targeted at random, connected to the blank tile, and I'm finding its current frame. And then I'm swapping this current frame with the frame of the blank tile, which is 9. So that's what is happening in these two lines, and then I'm just updating the position of the blank tile. And then I want it to shuffle many times, so that's how I've set up shuffling. I also set up a reset function, so that when I click on reset, all the tiles are reset back to their original positions, and also a blank tile is set to position 8. I also wanted to add a function where I click on a tile, and then the tile position swaps if it's next to the blank tile. So that's what's happening here. I'm finding the tile I've clicked on using the dynamic variable that I added to the overlay, and then I'm finding the frame associated with the tile I've clicked on using the tile array, the tile clicked as the index to the tile array, and then I'm using the current frame property. And then I'm looping through the connection array to check if any of the tiles connected to the tile that I've clicked on is the blank tile, which is at current frame 9. So that's what I'm doing here, and if I do find that there's a blank tile connected to the tile I've clicked on, I'm swapping the frames over, and I'm updating the position of the blank tile. And then finally I'm checking to see if the game is being won every time I'm clicking on a tile. The way I'm doing that is to loop through every tile to see if any of them are in the wrong place. So if their current frame is not equal to the tile number plus 1, and in that case it will say the game is not won. But if the game is won, if all the tiles are in the correct place, then I'm making the last tile visible. I'm also setting a latch to make sure that I don't allow the player to continue playing until they click on the new game button again. So that summarises how I completed the programming of this application. I want to give you a project to do, and I've set up a blank Flash file here, but I'll just show you what the project is. So the project is a matching pairs game. So there's 6 images underneath these to find, and there's 2 of each. So if I click on the tiles, I can view 2 of them at a time. It shows them for a second. And you see that I got 2, I matched 2, and then they vanished. So that's how it works. You need to find the pairs, and the game ends when you've got rid of all the tiles. The game shuffles the tiles at random, so when I click on New Game, the tiles are now in a different place. So I've set up a very basic Flash file, and you'll be able to find it. And the assets are in the library file over here, the library section. So there's 6 fruit images, and then the question mark. And you'll be able to set up the game using these images. I'll just go to this PowerPoint to give you some more details. So the project is to create a matching pairs game using the assets provided. There are 6 different card images, and when the user selects 2 cards, there should be a delay of 1 second before the cards are either hidden or are made invisible. And if the cards match, then the pair is removed. So I'll just give you a couple of hints about the strategy. I suggest starting by creating arrays of cards, much like I did with the sliding game, and also overlays as well, in the same way as the sliding game, and adding all the required mouse event listeners. So that will be the starting point, and remember you need to shuffle the cards at the start and when the user clicks on New Game. So I'll leave the blank file. I'll also leave a solution file so that you can check. I won't be going through it in the video, so this is a project for you to do on your own. And so good luck with that, and that's really the end of this section, although I will summarize the section in the next video. This is a summary of section 4. So we've talked about arrays and also two-dimensional arrays, and we decided that arrays are ways of storing groups of objects together. And arrays are particularly useful when you want to perform repeating computational operations on groups of objects. And we saw that arrays are often used with for loops, and I showed you how to structure a for loop. You set the start and end points of an integer, and also specify how the integer changes in each iteration of the loop. And for loops are often used with arrays because the integer can be used as the index to the array. We went on to talk about while loops and do while loops. The difference between the two is that do while loops will always execute their code at least once, even if the condition they are testing for is not met, whereas while loops won't execute their code if the condition they are testing for is not met. Both loops will continue to iterate while the condition they are testing for is met, and I told you that it is important that something happens inside the loop to ensure that the condition it is testing for is eventually not met. Otherwise, you can get an infinite loop, which will cause a bug in your program. I talked about the switch case statement, and I told you that this was similar to an if statement with a double equals operator. The difference between the two is that switch case allows you to test a variable for multiple different conditions and execute different code in each case, whereas the if statement will only allow you to execute one set of code for a particular condition. There is also the option of an else statement, which will allow you to execute code in the event that the condition tested for by the if statement is not met. And the switch case statement has a similar option, and it's called the default statement, and that will allow code to be executed if none of the other conditions are met. Finally, I showed you how to create a sliding game program, and I also left you with a project to do yourself. So that is a summary of section 4. I also want to leave you with some useful links. The top link is kindy.com, and that's a place to purchase encryption software, which will allow you to encrypt your compiled Flash file. If you don't encrypt your compiled Flash file, then someone else could purchase decryption software and decrypt your compiled Flash file into the uncompiled FLA file. And then they will have access to your code and also the assets in your library. So it's generally a good idea to encrypt your compiled Flash file. The second link, activeden.net, will allow you to purchase stock Flash projects, which can be used in your own projects. There are also links to purchase images, photos, and sounds. FlashEFF.com is an animation component. We haven't discussed components in this course, although we will do in the course subsequent to this one. OpenClipArt.org is a place to get free clip art. Dafont.com is a place to get free fonts. StackOverflow.com is a place to get help with your Actionscript coding if you need it. GitHub.com is useful if you are working on collaborative projects because it will allow you to keep a single up-to-date version of the software that you're working on. Pond5.com will allow you to purchase music and sound effects to use in your projects. Freesound.org is a place to get free music and sound effects for your projects. Milkmangames.com is a place to purchase code which will allow you to make money from advertising, primarily in mobile application programming. And we haven't discussed mobile application programming in this course, but I thought I'd leave you with this link anyway. The final two links, Congregate.com and Newgrounds.com, are places where you can see very good examples of Flash projects. You can also upload your own Flash projects to these sites. So that ends the course, and I hope you've enjoyed it. There is a course that follows on from this one, and that will include topics such as sound and video, loading and saving files, working with XML, and generating more advanced animations. So I encourage you to have a look at that course, and good luck with your Flash programming.